Hi, everybody. We are on lesson 5 of chapter 7 on characteristics of linear relations. We're talking about parallel and perpendicular lines today. So we're just going to do a really quick review of transformations. Don't worry about this. I don't think this is used much in this unit. I haven't looked through the whole thing, of course, but I don't think it's a big deal. A translation is just a slide. So if we start at point A, which is at coordinates 2, 5, so this is my point A, and I'm going to slide it 3 units to the right and 2 units up. So it's going to go 1, 2, 3 over and 2 up. And they said to call this point B. So B is now at 5, 7. Okay. And then we're going to take the same point A and we're going to rotate it clockwise about the origin. So since we started off here, we started from O when we do all our counting. It went 2 along the x-axis and then 5 up. We're just going to twist that a little bit. I'm going to do this in a different color. So this, we're going to go 2 up and 5 to the side. So can you see that, like, if I draw this L, it goes like that. And then, like, if I draw this L like that, we've rotated it. So this is point C, and that is at -5, 2. Okay, and then in a different color, I'll do this one in green. We're going to take point A again, and we're going to rotate it. Oh, I did that backwards, didn't I? I got my clockwise and my counterclockwise backwards. I'm so sorry. Well, let's just call that one, let's call that point C. Just fix it, point D. So this is point D, counterclockwise. Okay, so that is at -5, 2. And if we go clockwise from C, and I'll do that one from the first one, our arm is going to go down 2 and over 5, and our coordinates for point C is going to be at 5, -2. Okay, there you go. That's the rotations and the translations. Okay, we're going to look at some parallel line segments. So we've got one here that's AB, and we're going to translate it or slide it 4 units to the right and 1 unit down to form a segment CD. So I'm just going to take the endpoints to do this. So I'm going to use the endpoint here. It's going to go 4 units to the right, 1, 2, 3, 4, and 1 down. So this is going to be one end of my line, or my segment. And from here, we're going to go 4 to the right, 1, 2, 3, 4, and 1 down. And then I'm going to draw a line from one to the other, which is always fun on the computer. Okay, and I'm going to label that. This is CD. CD. Okay, and then I'm going to take my original AB and I'm going to slide that one 3 units left and 6 up. So 1, 2, 3, 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 1, 2, 3, 4, 5, 6. And that's EF. Okay, and then I'm just going to draw a line between those. And then I have 3 units down from my original to make another one. 1, 2, 3 down, and 1, 2, 3 down, and this is going to be segment GH. And I'm hoping that you're going to use a ruler. I just don't want to take the time. And they're asking us to calculate the slope of each of these. So I'm going to ask you to do that, and I'm going to pause. Okay? So hopefully you discovered that the slope for each of these, it counts out as -3/6, but that reduces to -1/2 for all 4 of those segments. And then we're asked, so the lines are all parallel. You can see that, I guess, by looking at it. I'm also telling you that. Make a conjecture about the slopes of parallel line segments. So I would say parallel line segments have equal slopes. Okay, is that fair? Oh, then this is a symbol for parallel. Parallel. Okay, next page. Okay, on the grid, plot the point A at 5, 2. So here's my point A. And draw a line joining the point to the origin 0 at 0, 0. So the origin is this middle point here, right there. Okay. And then rotate the line through an angle of 90 degrees clockwise and show the image on the grid. So let's do that in pink. And so here I went over 5 and up 2. I'm going to go down 5 and back 2. So this is my point. And I'm going to call this one A prime. Okay, so A prime, we read that as A prime. And it means that it is an image of A. We did something to A. Usually we moved it or we flipped it or something. Okay, so that's a common notation that we have. Okay, and find the slopes. So these are perpendicular. Okay, this is a 90-degree angle in here, and let's find the slopes of the two lines. So the slope of OA is a rise of 2 and a run of 5. And the slope of OA prime is a rise of -5 and a run of 2. And then if we multiply them together, 2 over 5 times -5 over 2, that equals -1. And I'm going to ask you to redo that for part B, for a different point B. Okay, so pause the video, do the next one. Okay, so hopefully you got that the slope of the first one is -1 over 6. It's always a good idea to make, it's a negative slope. Is it going down? Does it look like a negative slope? Yep, good. And the slope of OB prime is going up and it's much steeper, so it's got a higher number, right? Multiply those together, we get -1. So, and it did tell us that these are perpendicular as well. It told us that. Okay, so we're going to make a conjecture about the slopes of perpendicular lines. And that is that the product, well, you can put it in whatever words you want, product of slopes equals -1 if segments are perpendicular. So that symbol means perpendicular. Okay? Perpendicular, of course, means that they're meeting at 90 degrees. Sorry, I guess I should have mentioned that further. Okay, let's do this proof then. So we're gonna do a prove this conjecture that under a rotation of 90 degrees clockwise about the origin, where P at point AB becomes point Q, B A negative. So the slope from O to P is going to be B minus 0 over A minus 0, which equals B over A. And the slope from O to Q, this is O here, is -A, so y minus 0 over the x minus 0. So that's going to be -A over B. So if I multiply them, I get B over A equals -A over B, which equals -1. Oh, sorry, that's times, not equals. Times. Okay, so there, we've proven our conjecture. Well, sort of. I guess we haven't really proven those lines are perpendicular, but they are. I'm just going to take that on faith for today. We're not going to do a fancy proof over that. Okay, so recall that the slope of any segment within a line is the slope of the entire line, because we're only talking about same slope, straight lines. So they're parallel if they have the same slope. If m1 equals m2, they're parallel. And they're perpendicular if the product of the slopes is -1. Okay, so there's 3 different ways that you can write that. And the way we usually word that, if we're using words, is for perpendicular, each slope is the negative reciprocal of the other, provided that neither slope is equal to 0. Negative reciprocal, remember the reciprocal is what you get when you flip it. So if you flip it and change the sign, right, you multiply it by -1, so the sign changes, then the product is going to be, then that's your negative reciprocal. Okay, so let's just do some examples of this. We've got segment AC with a slope of 3 over 4. So if we're told that segment GH is parallel to AC, what's the slope of GH? Well, the slope is going to be 3 over 4 because it's parallel, it's the same. And if we've got another slope which is perpendicular, it's going to be the negative reciprocal, which means we flip it and change the sign. So since it was positive, we make it negative. Okay? And the slope of two lines are given. Determine if the lines are parallel, perpendicular, or neither. So the first thing we have to do is reduce our fraction here so that that's 1 over 4 so we can compare apples and apples. And those are the same. So we're going to write M1 equals M2. Therefore, slopes, or not slopes, lines are parallel, segments are parallel. Therefore, segments, lines, we're not being really picky about that, but lines are parallel. Okay? And then for this one, does that make sense? And you have to say what your justification is and what your conclusion is. You have to have both parts of that, okay? The what and the why. You have to have both. You can't just say that this one equals a quarter and this one equals a quarter and then leave it. You have to interpret that, okay? That's part of answering the question. Okay. So for this one, that's 5 over 7. We can't reduce that. That's 7 over 10. We can reduce that to 7 over 5. Those are reciprocals, but they're not negative reciprocals. So these are neither, okay? So the way we're going to write this is that we can do it symbolically. We can say M1 is not equal to M2, therefore not parallel. And then we can say that M1 times M2 is not equal to -1, therefore not perpendicular. Okay? Or we could write that in words. We could say M1, or we can, I mean, you know, there's not perfect words that you have to use. We could say slopes are not equal. Oops, only one L on equal. Therefore, not parallel. And then slopes are not negative reciprocals.
Mr. Davidoff, if you're still needing school, please contact the office. Mr. Davidoff, please contact the office. Thank you.
Therefore, not perpendicular. Perpendicular. Therefore, the answer is neither. I should put that over here. Therefore, neither. Because the question actually asked you, is it parallel, perpendicular, or neither? So your answer should be parallel or perpendicular or neither. But remember, you must interpret your result. Okay? So justification and result. You need both of those, okay? You can't just write down parallel. You have to tell me how you know that they're parallel, okay? Okay, we are so close to finished. This is a very short lesson. Oh, actually, we can pause it here. You can go and do the first set of questions, okay? And then come back for the second half of the lesson.